Hello and welcome to this Thorntail and MicroProfile demo. In this demo we're going to showcase some of the MicroProfile APIs in the context of a Thorntail application. So Thorntail is an open source framework for building Java microservices. It analyzes your application and collects just enough dependencies to satisfy the runtime needs of your business logic, and then packages that into a single artifact that runs standalone on the JVM. It also implements MicroProfile, which is a collection of microservice-oriented specifications driven by the Java community. So there's around 12 of these specs so far, and today we're only going to focus on a few of them for doing dynamic application configuration, health checking, distributed tracing, and a couple of RESTful APIs with some dynamic injection in Thorntail. So this demo features a web-based front end implementing a popular time-wasting application from the 1990s that many of you will recognize, and it uses a Thorntail backend to record the scores. So it all runs on OpenShift and integrates with its native capabilities for health probes, config maps, and tracing. So you can find the link to the code at the bottom of the screen for those that want to play along. So what I have here is an existing application. I've written a very simple one implementing this demo. You can see there's a simplified RESTful API that sits on the /API endpoint, and we're going to add some functionality to it with MicroProfile. So the way you add functionality is through, since I'm using Maven, is through adding dependencies on different MicroProfile specifications. So I'm going to add a couple of dependencies here. The group ID is for Thorntail, it's io.thorntail, and then we'll have a number of artifacts that we're going to add. We're going to add 4 of them actually, so let me add them here. So we're going to add MicroProfile-health. So this is for doing health probing, making sure your application's up and running. We're also going to do MicroProfile-config, which is for doing dynamic configuration changes to the application at runtime. The next two actually for tracing. So MicroProfile implements the open tracing spec. Thorntail implements the MicroProfile open tracing spec, and then we add an implementation behind that called Jaeger, which will collect the traces and then have a visual way of visualizing the traces and spans coming from our application. Okay, so with that in place, we're going to go ahead and do a first implementation of a health check endpoint. So I'm going to simply add a new class here to my project. We'll call it Service Health. And this is, again, this is be a very simplified health check endpoint. In order for it to be recognized as such, we need to add a couple of annotations. So we need to add the MicroProfile health annotation, and then we also need to add a bean annotation so that it is picked up by the bean processor. So in this case, our health endpoint, our health checking logic will be application wide. Okay, so we're going to add a method here. Before we do that, we need to implement an interface, which is the health check interface from MicroProfile. So when we do that, we can add the necessary method here called check, I believe, and let's just go ahead and implement the method here, or sorry, it's called call. So in this method, this is responsible for implementing the health check and returning either success or fail. So the basic way of returning success is simply to return this health check response. There's a couple of Fluent APIs here for building a response, so we'll just call it, give it a name of service health, and then build it as an up as a success, and then return that. So that's a pretty naive way. So basically this will provide some functionality, but we want to do some additional checking. So instead of doing that, we want to actually try and access our service before we return success. So let's go ahead and put this in a try catch block, and we're going to try and access our service. So in order to access our service, we need to inject the service instance in it, and it's called scoreboard service. And then we can try to actually call it get scoreboard. If that succeeds, and we'll return pass. If that fails for any reason, we will return a failure. So it's a very similar statement as the good one, but we want to put down here instead of up, which will return failure and then indicate to whatever's doing health checks, in this case OpenShift, that it's failed. We also want to add some data to it. So a reason of service failed, something like that. Okay, so there's our health check. It's a pretty simple health check. I'll go ahead and save that. Let's try and run that just to see what it looks like in real life here. So I'll open up my terminal and I'll just do Maven Actually, I don't even need a terminal. I can just run it from the my IDE here. So Maven Thorntail run. So that's going to go ahead and run the project. Once it comes up, we'll be able to exercise the health endpoint. Okay, so my application is up, so let's go ahead and open a new terminal, and we will exercise our health check endpoint. So let me just add a new, actually open up the terminal here, we'll just curl it, curl localhost 8080/health, and you can see it returns success because my application is indeed up. So the next thing we want to do is add some externalized configuration. So the way the scoreboard is initialized visually is it retrieves configuration information from the back end through this config endpoint. And you can see I have chosen a simple, obvious configuration element that I'm going to change. So right now it's a background. So right now it's hard-coded to red. So in order for us to inject or to bring in configuration, we need to inject a config property and we'll give it a name of microsweeper.bg, and we'll give it a default value of red. Private string background. Okay, so MicroProfile and Thorntail will automatically look in a number of different locations for configuration values, environment variables, system properties, and in our implementation I have it looking through a Kubernetes config map. So we'll simply find that value, hopefully, and we'll just put it here instead of having the hard-coded value. So with the health check and externalized configuration in place, the last thing I want to add is some open tracing goodness. So our RESTful API is here for the endpoint. We have three APIs. We have a get scoreboard, an add score, and a clear all RESTful endpoints on the /API/scoreboard endpoint. When I add a score, I have a call to an external service. And I'll tell you why in a moment. But basically, by adding the MicroProfile tracing tracing elements to my project file, my pom.xml, I automatically get tracing of the RESTful endpoint. So if I have a microservice application with a number of different services, I'll get nice, colorful tracing information across those services. In this case, I have one service, but I am making a call to an external service during this RESTful API for adding a score. So that external service simply calls out to a test API 3 times, and we want to make sure that gets traced properly. So in order to do that, we want to add an annotation on this method called traced, which will inform Thorntail through the MicroProfile API that this method should be traced, and it will create new spans as part of that trace when this method is started, and then that span will be completed when it's finished. We also need, since we're using a JAX-RS client, we need to register that client in the system so that external call will be recorded. So we do that through the client tracing registrar and configure that with our client builder, and then build that as our end result. So that's all I need to do to implement external outbound request tracing. So with all this implemented now, we're going to go ahead and deploy this out to OpenShift. And I'm just simply going to do a binary build of this code, and if that succeeds, then I will deploy that out to OpenShift. So while that's building, what's happening is the application is first built locally, and then that's packaged into a container image and a container image definition, and then shipped over to OpenShift in order for it to perform its binary build, combining the application with the OpenJDK runtime, and then packaging that as a final container image, and then deploying that out to my OpenShift cluster. So it looks like the build completed. So let's switch over to OpenShift and see what that looks like. So you can see I have my application deployed here. It's currently building. I also have an instance of Jaeger, the open tracing implementation, waiting for traces to be registered with it and fed back to it through its collector. So we'll wait for that build. Actually, I'll fast forward this build so that we don't have to wait too long and get the application up and running. Okay, so the application is done building and deployed out to my OpenShift cluster. If I look at the deployment, I can see that the readiness and liveness probes are indeed responding successfully as the application is considered running. So that's all good. So let's go ahead and take a look at the application itself. So if I click on the URL here, it'll load up the application here. So you can see my application is running and it has a red background, which is my default value. If I go ahead and play a couple times, you can kind of get an idea of what this game is. It's Minesweeper from the 1990s, and every time I complete the game, this value is added to the scoreboard, and that's being persisted on the back end. Okay, so if you recall, you can see the red background here. If we switch back to the code momentarily, you can see I have created a custom MicroProfile config source, and this is what's responsible for retrieving the config map so that I can use config maps as my dynamic configuration mechanism in my application. So it looks for a specific config map called MicroSweeper, and it fetches those using the Kubernetes Java client. So what I can do is if I go back to the OpenShift console, I can see if I go to my config map, I can see I have one. I've created it already. It has a background of red, which is why we see the value, which is why we see the background is red. So let's change this to green and save that. And then if we cycle our application to pick up the new value, then if we switch back to the application and reload the page, we should have a green background once it completes loading here. So here's my green background, and my application is up and running with the new configuration. What I'm doing as I'm playing is I'm generating those traces for my application. So if I can play a couple times here and fail, obviously, and if we switch back to go over to Jaeger and have a look at it, we can see it notices the MicroSweeper service here. I can click Find Traces, and I can see a number of traces that I got for free based on each of the RESTful endpoints like get scoreboard and get config, and the more interesting one, which is add score. This is the one that's calling that external service. So this is a trace of that one of the most recent calls I made, and you can see the individual spans here, one for the overall call to the RESTful API, one for that call to my external method called call external HTTP, and then you can see individual traces for each of the times that I called the external service. So this is super handy to figure out if an application has performance problems, what's happening under the hood, and again, you get that for free using MicroProfile and Thorntail. In fact, all of the APIs I've demonstrated so far are essentially free. You add it to your project, you make a few additions to the code to add either annotations or other mechanisms depending on the specification, and you get a lot of functionality out of the box with MicroProfile and Thorntail. So I hope you enjoyed the demo. Again, for more information, check out microprofile.io and Thorntail.io.